Hey everyone, my name is Andrew Rodriguez, and today's speech is the skill building speech. And for my topic, I've chosen to talk about what a full bridge rectifier is, how it works, and its applications. For those of you who don't know what a full bridge rectifier is, it's a circuit that converts AC into DC, so alternating current into direct. And this kind of circuit is used in, for the most part, any appliance that you plug into your outlets. Your LED lights, or LED lamps, your computer, a laptop, your coffee maker, phone chargers, etc. All those things have a full bridge rectifier within them. And before we go over how it works specifically, I'm going to go over a couple symbols of the components that are used within the circuit. So this first one represents your AC voltage source. This is your outlet. Our outlets have 120 volts. This second one is a transformer. We have a step up and a step down transformer. Step ups are used to raise your voltage, step down is to lower. The step downs are what you're typically going to find in your appliances. And the way it works is it depends on the ratio of your windings from this primary coil to your secondary coil. So if you had a 10-to-1 ratio, your 120 volts would be divided by 10. So it would come out to 12 volts on this end. And if you wanted 5 volts, you would have a 20-to-1 ratio, and you would divide your 120 by 20, and that gets you your 5 volts. These lines right here represent an iron core. If there's no lines, it means they have an air core, so nothing's there. They have a variety of patterns of lines, and it basically means different types of cores, and they all have different applications. This third component is called a diode, and it's polarized, which means it does matter how you connect it to a battery. So you can see a positive for an anode and a negative right here, which is your cathode. So the triangle is your positive side. And on an actual diode right here, you can see this silver side, that is your cathode. Now this next one is called a capacitor, which is kind of like a battery. However, it can't store as much energy within a capacitor as you would a battery. So that's why they're not used as batteries, basically. However, they do have their own applications, and they can charge and discharge a lot faster. I also have two types of capacitors. This one is non-polarized, meaning you can hook it up in any way. This one is polarized, and this would be your negative side. So you hook it up wrong, these things can blow. This next symbol is a resistor. These are used to control current, and they also are used to divide voltage. And this would be a resistor right here. Now that we've gone over all the components, we can go into circuits and how they work. So initially you get your AC voltage from your outlet, and that goes to your transformer, steps down your voltage to the appropriate level. And initially you have one side being positive, and it's going to go through your diode, go through your resistor, the next diode, and to ground. And then when it goes to the negative cycle, this side is going to be your positive and this is your negative. However, it flows from positive to negative. So when your electrons try to flow this way, this diode is connected backwards essentially. And what you end up getting is these choppy bumps because the negative cycles aren't there essentially. Now for a full bridge rectifier, it basically creates a pathway, two pathways. So regardless if it's positive on one side or positive on the other side, there's always a pathway for the electrons to flow, and they end up passing through the resistor in the same direction, no matter what. So each cycle is being used, and you end up with this choppy bumps, which is like the negative cycles are flipped almost. And this still isn't an ideal DC current because it's choppy. So if you had like an LED light, it would probably flicker. If you had a motor, it would probably be really choppy. So what this capacitor does is it holds energy, and when it is on these down trends, the capacitor will hold the voltage until it reaches the next peak, and it basically just keeps it smooth, and you end up with this smooth DC voltage, which is what you ideally want. And that's the end of my speech. That's all there is for a full bridge rectifier today. Thank you for listening.